Hello, this is Justin Lopez, and this is me showing my microprocessors 2 final. It's chess on the TM4C microcontroller. So here's a short video showing the overview.
So this video is going to showcase this chess game I made, just a little overview. So this is just the pass and play version where two players can play against each other. You can see it's white's turn, then it's black's turn, stuff like that. Pretty straightforward. And everything works, kind of just as you would imagine. Nothing crazy, just chess. So you can see like I have sprites for these pieces. You can see the white and the black pawn sprites. You can see here's the knight, the rook, the queen, the king, the bishop, and yeah, just a chess game.
So yeah, that showed my chess game. You can see the sprites and everything. It's played entirely with the joystick, and yeah, we'll get into more specifics throughout this presentation as well. So first, some of the RTOS components, specifically the semaphores. There's four main ones that I use here. One's for the exclusive access to the screen. It's just a mutex for the screen, so multiple threads can't write to it at once. Because I have multiple threads writing to it, one moving like the pieces, one doing the move highlighting, stuff like that. The next semaphore is this move select semaphore, and I have separate threads for doing like the move gathering logic as well as making the actual move. So this semaphore is used to signal from one thread to another that a move has been selected and then it needs to be made. The next semaphore has like a similar purpose that it's being used to signal one thread to another. This thread is being used to signal from the joystick thread to the like actual like display thread that the user wants to move the cursor. Yeah. And the last one is another signaling semaphore. This one is just used to signal from the aperiodic joystick callback, and it signals and wakes up this other thread that actually handles the joystick press. And getting into those threads, so you can see there's three main threads here. First is this main logic thread. This does the actual move generation, like legal move generation, redrawing of pieces, stuff like that. So all of like the main chess, the stuff is going to be in this thread. And then the other two threads are mostly gathering user inputs and like processing them into like a move format. So the first one here is move selection thread. It does highlighting the square drawing basically. And the third thread here is handling the joystick press. Yeah, and the joystick press has a couple things that it does. The joystick press has to do, sometimes it restarts the game, sometimes it needs to highlight possible moves, and sometimes it needs to select a move. So this thread handles all three of those situations. And so I have one periodic thread, and it's gathering joystick input. The joystick input is like the left, right, up, down accelerometer joystick input. And then like if this input detects that the user wants to move the cursor on the screen, then it signals that other move selection thread that we talked about earlier. And I have one more like sort of thread-like component. It's this aperiodic thread or callback, like the GPIOD interrupt callback. And the GPIOD is where the push button on the joystick is. So yeah, this callback just signals the other thread, the read joystick press thread, to wake up and handle this button press. And this callback also does this very quick debounce logic with the timing. So yeah. Those are the main real-time operating system components that we have going on. For the actual chess logic, I'll talk about for the next few slides. So first, just some components for my chess logic that I have going on. I have a bunch of different structs used to like represent different like parts of the chess game, sort of. So I have chess move, chessboard, move list, and there's more. There's like undo move and such. Chess move like represents a move from one square to another, and it also holds like the type of the move, like en passant or like double pawn, that kind of thing, like a standard move, stuff like that. Chessboard is the struct that you see in this image here, and it represents the entire board. An important part of this is I want this to use as little space as possible, because when you do the chess like engine that calculates moves that are better than other moves, stuff like that, um, that like spawns a bunch of boards, from my understanding. Or you can do it on the same board and do a bunch of undo moves, that kind of thing. But it's basically good, especially in smart microcontroller, to represent the board as small as possible. And one way you can do that is using bitboards, which is what this other bullet point talks about. Bitboards are these uint64 8-byte kind of variables. So you obviously know that this has 64 bits in it, and a chessboard is 8 by 8, which is 64 squares. So like one of these uint64s can represent an entire board. At least it can represent an entire board by like marking each square as a 0 or 1. So what all of these are is this is a bitboard for the king positions. So like all of the positions on the board that have a king, this will be marked like by a 1 bit. The bottom left square, or A1, is going to be the 0th bit in this variable, or like the least significant bit. Um, so yeah, that's the idea there. So like this is where the kings are, the queens are. This has all the white pieces, all the black pieces, that kind of thing. These other two things I have here are like for holding en passant and castle information, because once you move, like once you make another move, like if you move your rook again, then like if you move your rook somewhere and then move it back, you can no longer castle. Same with en passant. Like if you miss the one move that you can do it, you can no longer do it the next move, that kind of thing. That logic is you like these variables are used for that logic. So yeah. Move list is another thing. Move list is like an array of moves and also has some other information, but it basically is used to like hold a bunch of legal moves at once. Yeah, hopefully all that makes sense. So the process of generating legal moves, this is like the most daunting challenge of this project. This was the most daunting challenge of this project. And there's a lot of code that kind of goes into it. Um, so first, I'll go through this bullet points, which talks about the process of sort of generating a pawn move, for example, and then I'll talk about the code that's shown below. So when generating a pawn move, the first thing that you can do is shift your pawn bitboard. So for example, if you want to see all the pawns that can move forward by one piece, like straight upwards, um, you can shift all of them 8 times to the left. So this would be like for the white pieces, if you shift the pawn bitboard 8 times, like 8 bits to the left, it pushes all of the pawns up one rank, which is the move. You know what I mean? That pushes them up one rank. And then you need to check to make sure those pawns aren't on a square another piece is on. So like you shift all the pawns and then you make sure that all those shifts were valid. And if they're not valid, like you take them out of that bitboard. And so you do that kind of thing, and then you're left with a bitboard that has only like valid moves. The only thing that you have to check now is you have to make sure that the board doesn't end up in check, or like your king doesn't end up attacked after making the move, which is basically checking that you can't move a pinned piece. That's what this third bullet point is talking about. And that's also what this image to the right is doing. It needs to make sure that your move isn't like leading your king in a check, because that's an invalid move. So yeah, I will then talk about these two pictures. So the one on the bottom right, like I just talked about, checks if a move is legal, and it does that by making the move, checking if the board is in check, and then undoing the move. This function is like pretty readable and hopefully pretty self-explanatory. So you can see that it makes the move, it gathers the undo info. So undo info is like the information necessary to undo the move, basically. It's like another struct. And whenever you do make a move, it always returns undo info, so you can undo moves. It's useful for a lot of reasons, but it just makes things more efficient and take up less space, basically. You don't have to store multiple boards. You can only store like one board and then the undo info, if that makes sense. So yeah. And then we check if the board is in check, then undo the move, and then return whether or not it was in check. Pretty straightforward. This thing on the left is this function that adds all of the like possible legal moves for a current board. This one is also pretty readable. You can see that it just adds the pawn moves. This one adds knight, king, rook, bishop, queen moves, that kind of thing. Pretty straightforward. One thing that's pretty neat is that I have these two functions, add slider and add non-slider moves, that I'm reusing. And the way that works is all of the pieces in chess are moved by shifting bitboards, basically, or like it can be calculated by shifting bitboards. So for instance, like the knight move set, there's like 8 possible moves a knight can make. And then like to calculate each of those moves, you can shift the knight 8 different ways. So if you shift it by like, let's see, it's like 8, 16, 17 bits, like you can do that up to and to the right one. That's kind of the idea. And then so the shift set sort of has like all 8 of those shifts that the knight can make. So yeah, hopefully that makes sense as well. But that's how the move generation is working. And that was like the most daunting, like difficult part of this logically and such. Okay. So there's also a chess bot. This bot though is not intelligent. It just picks a random move from the like list of legal moves. But you can enable it by hash defining bot at the top of the threads file. And it's seeded with the system time. The system time variable is from the RTOS, and it's in milliseconds. And since the user goes first, this seed doesn't happen until after the user goes, and then it's like the bot's turn to go. So using this variable and like seeding it like this is a good way to make it random, basically. Um, but yeah, so this is pretty straightforward too. This is the bot making a move. You seed it and you calculate a random index from like the possible moves, and then you get the move here. These two are a user making a move. So the way this works is this semaphore is obviously we're waiting on it, and then this thread wakes up when a move is selected. This move select is happening from, I'm pretty sure, the joystick press thread, which also fills this move index variable. So the joystick press thread fills the variable and then signals the semaphore when a move is like selected by the user. And then this thread wakes up and then actually does the move. And then after this block of code, it has the redrawing logic to redraw the pieces on the board. So yeah, that's basically everything about the game. And then here's a bunch of videos showing
So quickly
various
here, I'll
parts.
showcase just the fastest possible chess game, which is pretty funny. So first is this, and then black does this to release their queen. Then white plays g4 with the pawn, and then there we go, there's mate in like 2 turns. And then you can see black wins, that's checkmate, and I can restart the game again by clicking on the joystick, which starts the game over. So you can see that checkmate works out.
So here in this video, you can see checkmate, and you can see what happens when the game ends. It says the team that won here at the bottom, and it also freezes the screen until you press this joystick again. So yeah, that's checkmate. And here's another video showing off check. Maybe I can full screen.
Quickly here, I'll show what happens when
Okay,
you are in check. So here I'm just going to release the black queen like this. Okay. And then if the black queen attacks the king like this, you'll see that we're in check. So we can't make moves with random pieces like this pawn. It won't let us because we're in check. We have to get out of check. So the legal moves include move like this. It looks like that might be our only legal move. This one right here. And then if black keeps attacking, you can see that we're in check again, so we can't move random pieces like this. We have to get out of check by stealing this piece. And then we're no longer in check. You can see we can do whatever move. Yeah.
nice. That was check. Oh, that was check. And then here's en passant.
So here, I'm going to showcase on.
Here's en passant.
So here, I'm going to showcase en passant, which is like a weird kind of almost like niche rule that hardly comes up, but it happens when the pawn moves forward twice. So that if the pawn does a double pawn and then ends up next to an opposing pawn, only on this turn, this pawn can take this pawn in like a passing motion like this. If you saw what just happened, that was the move en passant, and it's like a special case kind of rule. But yeah, that's all.
Nice. That was en passant. And then here's the promotion.
So now I'm going to showcase promotion in my chess game. So promotion is when you get a pawn to the other side of the board. What happens is that the piece promotes to a stronger piece. So normally you're able to pick if it promotes to a queen, king, bishop, or rook. But in my case, I just didn't have enough time to implement that, and I just have it promoting to a queen by default. It wouldn't be super hard to implement that. Maybe implement these buttons or like a prompt for the user, but for now it just automatically promotes to a queen. But you can see that the promotion works. So yeah.
You might have heard I definitely said something wrong there. You can't promote to a king, you can promote to a knight, but you get the idea.
So now
And then here's the bot.
The bot portion of this, the chess bot portion.
This video is better.
And I also want to talk a little bit about the move highlighting. So you can see when you select a piece, it shows its legal moves, which is really pretty and nice. And then if you select a different piece, it shows that piece's legal moves. By the way, I'm clicking on the joystick for all of this to happen. Maybe I can zoom out or... No, I think the zoom in is good. But yeah, you get the idea. And then the cursor is always green like this. But then if you are hovering over a possible move, it's purple. And then if you click the joystick on one of those, it actually makes the move. So that's how that highlighting works. And you can go like down, right, left, and it would go overlap to the other side of the board. Okay, so that's the move highlighting. And I also want to talk about the bot that we have here. You can see that this opponent, I'm not making those moves, it's making them on its own. So every time I make a move, it makes a move. Yeah. So this bot is not intelligent really in any way. It's just picking a random move. I guess I could have done something simple, like if it sees a piece to take, it just takes it as well. So I can implement some like basic move logic, but I really wanted to implement a bot, but I just didn't end up having enough time. But yeah, you can see that it's making all those moves. And so I can play against it as the white pieces, just like this. And it's pretty cool.
Nice. Yeah, I think that shows everything. So that's my project, chess. It was a lot of fun. And yeah, thank you.